Hey everyone, welcome back to The Explainer. Today we are taking a seriously profound philosophical leap. We're going to be talking about the explorer's mindset. It's that fascinating shift from just, passively observing the world around us to really truly investigating it. And it turns out making that leap requires a completely new framework of thinking. So let's just jump right in. Okay, so here is the central, mind-boggling problem that literally every single scientist faces. How do you study a world that is just impossibly complex? I mean, really think about it for a second. The natural world is infinitely detailed. If you want to study a forest, where do you even start? Do you look at the giant trees, the individual leaves, or are you looking at the microscopic cells inside those leaves? It's completely overwhelming. So how exactly does science make sense of all this complexity without getting completely lost in the weeds? Well, our roadmap for figuring this out comes straight from the introduction to the science text Exploration, and it marks a really important threshold. We are officially stepping out of the middle stage of science, the stage where we basically just learn the facts, and we're entering this exciting new era of deep exploration. And to do that, we have to fundamentally change our whole relationship with information. To really grasp this shift, let's compare the two mindsets. In the middle stage, science was really just about inviting you to be curious. You looked around, you asked some basic questions, and you basically learned what we know. But deep exploration, that demands a whole new level of rigor. Science at this secondary stage isn't just about what we know anymore, it is fiercely, absolutely focused on how we know it. We're asking, how do our basic observations turn into strict measurements? How do we build symbols and models, test them out, and then revise them? And to constantly remind readers of this rigorous new mindset, the authors of the text made this brilliant little design choice. If you look closely, even the page numbers of this book are framed by two very specific tools, a magnifying glass and a compass. It's a subtle touch, but these are incredibly powerful symbols that represent the exact dual mindset you need to actually survive all this complexity. Let's break those down. First up, the magnifying glass. In our scientific toolbox, this represents the absolute non-negotiable need for intense, zoomed-in observation. It's there to be a constant reminder to deliberately look for patterns. You've got to pay strict attention to those tiny, microscopic details that might otherwise just slip right by you. It is essentially the ultimate tool of focus. But here's the thing. Focus needs guidance. And that brilliantly illustrates why we need the compass. Because if the magnifying glass is all about zooming in, the compass is about knowing where you're actually going in the first place. It reminds us that true exploration needs direction. You have to choose the appropriate models, ask the exact right questions, and, maybe most importantly, you have to know the limits of your own ideas so you don't just wander off aimlessly. So, we've got our focused observation, and we've got our directed purpose. But how do we actually apply that to a universe that is infinitely detailed? Well, here is the secret. To make sense of complexity, science uses models. It's that simple and that profound. Models are basically the ultimate tool for navigating through the chaos. Now, what are models really? They're simply simplified ways of looking at real systems. They don't even try to capture every single tiny detail of reality because, let's face it, that's literally impossible. Instead, what models do is strip away all the extra noise. They focus strictly on what is most important for whatever specific question you're asking, filtering the massive, chaotic natural world down into something our human minds can actually process. And we see this universally, across every single scientific discipline. Take physics, a massive, complex, moving car might just be represented as a single tiny dot on a graph. Or in chemistry, insanely complex atoms are just drawn as simple spheres and sticks. In biology, living, breathing cells are reduced to basic 2D diagrams. And earth science, our massive, jagged, completely uneven mountainous planet, is often just treated as a perfectly smooth, layered sphere. It's everywhere. Now, what's really interesting about this is what it implies about the whole scientific process. Building these models actually requires making assumptions. It requires you to deliberately ignore certain details. Think about it. To understand the raw math of gravity, a physicist might just completely ignore air resistance altogether. Or to understand how a heart acts as a pump, a biologist will purposefully ignore the millions of individual cells that make it up. They just purposefully leave that information out. The source text frames this absolutely beautifully. It says, remember that these choices are not mistakes. They are done on purpose to keep things simple enough, but still allow us to find answers to what we are looking for. I love that. It's such a cool paradox, right? Intentionally ignoring details isn't a scientific error at all. It is a highly calculated, incredibly powerful strategy for cutting through the noise. And this whole philosophy leaves us with a really clear, empowering three-step methodology for the secondary stage of science. Step 1. Identify a complex system in the world and grab your compass to find your direction. Step 2. Build your model by deliberately ignoring the extra details. Just totally strip away the noise and make your assumptions. And finally, step 3. Grab that magnifying glass, focus right in on your simplified model, and find those specific answers you're looking for. So here's the thing. This scientific framework, it's not just for textbooks. It's a legitimate way of viewing the world. So I want to leave you with this thought. What complex problem in your own life or in your work could you solve right now by simply choosing to ignore the details? Because sometimes the smartest thing you can possibly do isn't to look harder at the chaos. It's to step back and build a simpler model. Thanks so much for exploring this with me today, and I will catch you in the next explainer.